Hello, this is Dr. Grande. Welcome to my video on interpreting the output from a multiple regression using SPSS. As always, if you find this video useful, please like it and subscribe to my channel. I certainly appreciate it. I have in the SPSS data editor 4 variables. These are fictitious data. I have an ID variable. I have 100 participants in this design. And I have 2 predictor variables and 1 outcome variable. So for the first predictor variable, this one is named career limitations. So let's assume that we have participants that are in a career training program, and we develop this series of questions to determine how many limitations they're facing in terms of getting back into the workforce. And these questions go through a scoring process and end up in this variable, and this is an index. So certain characteristics or occurrences may be weighted more heavily than others. Potential limitations could include a criminal history, low educational level, an active substance use disorder, and other factors. So a higher value in this variable would represent more limitations or more severe limitations. Then we have experience. And experience would be measured in years. This would be the number of years a participant had either a full-time or part-time job. Then we have days until employed. So after the completion of the career training program, the number of days until the participant finds employment is measured. And for this example, the maximum would be 365 days. So we could have a couple hypotheses here before we conduct a multiple regression. Career limitations, we believe the higher the number on the career limitations variable, the longer it would take to become employed. And for the experience variable, the more experience associated with fewer days, with a smaller number of days until the participant becomes employed. Now there are assumptions for multiple regression, but here I'm going to be focused on the output. So I'm not going to check those assumptions, but just know there are assumptions before running a multiple regression that would need to be checked to make sure that these data would be appropriate for that statistic. So here under Analyze, Regression, and Linear, I have the dialog for linear regression. And you can see there's one space for a dependent variable or an outcome variable, and that's going to be days until employed. And you can have multiple independent variables or predictor variables. In this case I have 2, career limitations and experience. Under statistics, by default we have estimates and model fit. I'm just going to add R-squared change and descriptives here, as well as the confidence intervals at the 95% level. Continue, and I'm not going to make any other changes here under the buttons on the right. So I'm ready to conduct the multiple regression. Click OK. And let's take a look at the tables. We have the descriptive statistics here up top, then correlations, variables entered and removed. Both of the variables I put into the model used here. Model summary, we have R-square and adjusted R-square. We're going to be interpreting adjusted R-square. So with this model we have the 2 predictor variables, the 1 dependent variable, and we have an adjusted R-square of 0.237. This tells us that 23.7% of the variance in the dependent variable is explained by the independent variables. Moving down to ANOVA, we have a statistically significant finding here, less than 0.05 for the p-value. Then we have the coefficients table. So we have here career limitations, experience, and the unstandardized coefficients. For career limitations it's 2.658, and for experience it's negative 4.044. We also have the standardized coefficients and p-values. So let's start with the p-values here. For career limitations, we have 0.009, that's statistically significant. So this variable has a statistically significant impact on the outcome variable, on the days until employed. Taking a look here at the p-value associated with experience, you can see this is also less than 0.05. So we have a statistically significant contribution from the experience predictor variable. Looking at the unstandardized coefficients for career limitations, we have a value here of 2.658. And what this tells us is as the career limitations index increases by a value of 1, for every 1 unit of change for career limitations, we're going to see a 2.658 change in the days until employed variable. So 1 point on the career limitations, 1 additional point, is associated with 2.658 days increase on the dependent variable. So the more career limitations we have, as measured by that scale, by that index, the longer it takes the participant to find employment. Experience, however, works differently. With the experience independent variable, we have a negative value for the unstandardized coefficient, negative 4.044. So what this tells us is as experience increases by 1 year, because experience is measured in years, that's the unit of analysis for that variable, the number of days until employed decreases by about 4. So more experience associated with a smaller number of days of unemployment. Now, when thinking about this in terms of standard deviations, we would look at the standardized coefficients. So for every full standard deviation of movement we see in career limitations, for every 1 standard deviation of movement we see with this variable, the dependent variable, days until employed, increases by 0.233 standard deviations. For every 1 standard deviation of movement we see in experience, as experience increases by 1 standard deviation, we have a decrease on the dependent variable, days until employed, of negative 0.436 standard deviations. And then moving over to the confidence interval, and this is for the unstandardized coefficient we interpreted before, we can see there's a 95% chance that the actual value of the unstandardized coefficient is between 0.671 and 4.644. And the actual value for experience, we can be 95% confident that it's between negative 5.663 and negative 2.426. I hope you found this video on interpreting the output from multiple regression SPSS to be helpful. As always, if you have any questions or concerns, feel free to contact me, and I'll be happy to assist you.